Good day, viewers. So in this video, we're going to look at the quadratic nature of roots, okay? So we are going to check out this red guy inside of our square root. That is the b squared minus 4ac, and then we call him a delta, okay? Now, what happens is, he's the one who determines the nature of roots. Now, let's say our delta is less than 0, meaning it's negative, okay? When it's negative, your roots cannot be real. Because if we plug any negative integer here in a place of b squared minus 4ac, okay, we are going to get a solution that is not real. We're not going to get any solution. We're going to get non-real solution because we cannot put a negative inside of the square root. Remember, we cannot put the negative inside of the square root. And that's why when it's less than 0, we get non-real solutions, okay? Now let's look at it when it's 0. We say our delta is equals to 0. If our delta equals to 0, our solution is going to be based on only the minus b over 2a. Okay? The plus minus the square root is no it's just plus minus 0. So we just ignore it. It falls away. It falls away if the b squared minus 4ac is 0. Now, this means our solutions will be equal. Our solutions we will get only one solution, and then, but remember, we are dealing with quadratic. We have to find the two values of x, the two roots. Now those two roots will be the same. They will be the same thing. They will be minus b over 2a. Okay, that's when you get the equal roots that are real and they are rational. Okay, you get equal roots that are real and they are rational. Now the other possibility is that our delta will be greater than 0, and then it's again a perfect square. If that's the case, you are going to produce the roots that are real, they are unequal, and they are rational. Now let's say our delta is greater than 0, and then it's not a perfect square. If we take a square root of a number that is not a perfect square, chances are we're going to produce an irrational number. Right there, we're going to produce an irrational number. Again, when we subtract or we add it to the b, to our minus b, and then divide by 2a, and then that's when we produce an irrational solution. The solutions will be irrational. Now the solutions will be real. Yes, they will be real, and then they will be irrational. Irrational, and then again they will be unequal. You must know that they will be unequal. Okay, now let's look at some questions so that we can get a clear picture of what we are talking about and what we are dealing with here. Okay, so the first one here says, discuss the nature of roots of x squared minus 2x minus 6 equals to 0. Discuss the nature of roots of that equation without solving for x. Okay, without solving for x of that equation. Let's look at the solution that the solution that we are going to get. If is the first, remember we have 4 cases: when it's equal to 0, when it's less than 0, when it's greater than 0 twice, when it's greater than 0 the first time is when it's a perfect square, and the other case is when it's not a perfect square. Okay, let's look at that. Now we have to know our A, B's, and C. That's all we have to know to solve the, because we are looking for delta. Remember, delta is b squared minus 4ac. This is all we have to do. After getting our A, B, and C, we just calculate the value of delta to answer the question, and then we are done. Okay, let's look for those values of A, B, and C. We say our x squared minus 2x minus 6 represents our ax squared plus bx plus c. In this case, our a is 1, our positive b is our negative 2, our positive c is our negative 6 there. because it's a x squared, that is 1x squared, plus bx. Our positive b is plus negative 2. That will produce that negative 2 that is there, x. And then our plus c. If we add a negative 6, then we get that negative 6. So our a is 1, b is minus 2, c is minus 6. Please don't make mistakes of leaving the negatives outside. That's why I want to make it clear like this, to write them on top of each other like this, so that you can clearly see which one is which one. Okay, now let's calculate the value of delta. The delta is b squared is minus 2 all squared minus 4, a is 1, c is minus 6. Okay, and then what we get is we're going to get 4 plus 4 times 6 is 24, and this is going to be 28. Okay, 28 is positive, right? So we know that our delta is greater than 0. Okay, is it a perfect square? No, it's not a perfect square. Perfect squares are, remember, 1 squared 1. 1 is a perfect square. 2 squared 4. 4 is a perfect square. 3 squared 9. 9 is a perfect square. 4 16. 5 25. All those ones are perfect squares. Anything other than that is not a perfect square. Anything in the middle of those ones is not a perfect square. Okay, now 28 is not a perfect square because it's between 25 and 36. 36 is the perfect square of 6. Okay, now since it's not a perfect square, we're going to produce the solutions that are real. The solutions are going to be real. They are going to be irrational, and then they are going to be again unequal. And then that's how you get that. That's how you have discussed the nature of roots. You answered the question. They are real, they are irrational, and they are unequal. Okay, let's look at the last two questions. So number 2 says, it is given that x equals to minus 2 is a root of the equation that is r x squared plus bracket of r plus 3 into x, and then minus 4 equals to 0. Find the value of r. Okay, let's go and find the value of r. We say, since they give us a root, and the equation that they used to get that root, we can use the equation together with the quadratic equation to produce the same root. So if we want to solve for x, we can just plug in minus b plus minus the square root of b squared minus 4ac, everything divided by 2a. Okay, and then we say, now let's substitute into our formula. Remember, we have our x is minus 2. So what we're going to do is to substitute that x there. The x that is minus 2, we're going to substitute it here. We say minus 2 will be equal to minus b is r plus 3 into brackets plus minus the square root of r plus 3, and then you close, you square, minus 4, a is r, c is minus 4, everything over 2a, a is r again. And then from here, what we can do is we can multiply both sides by 2r to remove this 2r there. Okay, and then we simplify the brackets on the numerator of this fraction that is on our left hand side. Let's do that. We say we're going to multiply here with 2r. Okay, and then we multiply this minus 2 with 2r as well. And then from here, we say we're going to get our answer as 4r, the negative 4r, because of the negative and a positive is negative. So we have negative 4r equals to, on the numerator we have minus r minus 3, and then we have plus minus the square root of r squared plus 3r plus 3r, that's plus 6r, and then plus 9, and then we have a plus, a plus because of we have minus and a minus, there's plus, plus times a plus is another plus, plus 16, 4 times 4 is 16r, and then you divide everything by, you're supposed to divide everything by 2r, but then this 2r is going to cancel with this 2r because we're multiplying with 2r on both sides, remember, okay? And then from here, we can take the square root of the plus minus the square root, we can take it to the other side, and then bring the minus 4 to this side, okay? Let's do that. When we do that, we get the plus minus the square root on the other side will also be plus minus the square root of the r squared plus 6r and 16r, that's 22r. So we just write plus 22r there, and then plus 9 equals to minus r plus 4r, that is plus 3r minus 3, the constant that is minus 3 here, and then from here we can square both sides to remove this square root. Now let's remove the square root. We're going to say we put everything inside of the bracket, we square both sides, and then the plus or minus here is going to be a plus, because a plus is going to be a plus, and the minus as well is going to be a plus, because minus times minus, it's a plus, plus and a plus, it's a plus when you multiply both together, okay? And then we have the square root being removed as well by the square, okay? And then we have our r squared as our answer there, r squared plus 22r plus 9, that should give you, this side you have 3r all squared, that is 9r squared, and then you have minus 3r, minus 3r multiplied by 3 twice, that's minus 18, because you have minus 9r minus 9r, that's minus 18r, and then minus 3 all squared, that is plus 9, okay? Now from here, we can just collect like terms. You can take all of these guys to the other side and solve for r, okay? Let's do that. We say we leave 0 on this side. On this side, what we have is we have 9r squared minus r squared is 8r squared minus 18r minus 22r, that is minus 40r, and then you have 9 cancelling with 9, it's positive 9 minus 9, that is just 0, it falls away, and then we have here equals to 0, okay? Now when we are at this step, we are almost there. We say now we take out our common factor, that is our 8r. We are left with r, because we have 8r squared divided by 8r, that is just r, and then minus r cancels with r, 40 divided by 8 is just 5. We write 5 there, equals to 0. So for this to be true, it's either 8r is 0 or our r minus 5 is 0. And then we have our r is 0 or our r is 5. Now we are not done. We have to go back and test these solutions if they are really true, because at some point we dealt with with a set equation, okay? At this point, and everything that is above this one, we dealt with a set equation. It was given to us as a set equation. Let's go and see if both the solutions will work, and if they both work, and then they are both the solutions to the problem, okay? Now what we want to do is we want to test this. So the way we will test this is we will just plug 0 in the place of r in a given equation, and then we have 0x squared plus 0 plus 3 is just 3x minus 4 equals to 0. If we do that, we get our x. You see, it's no longer quadratic because this part goes away, it falls away. So we just, if we solve for x on this equation, we get one solution. We get one solution, that is x equals to 4 over 3. And this is not acceptable. Remember, One of the solutions that we must get is x equals to minus 2, x equals to minus 2. This is a guaranteed solution that you must get when you solve for the equation that is given there, okay? But now since we don't get this solution when you solve for x here, we have a problem. That is why we say this one is not acceptable, okay? Now let's check when r is 5. We replace every r that we see in that equation with 5. We say we have 5x squared plus 5 plus 3, that is just 8x minus 4, that will be equal to 0. From here, we can just proceed and use the quadratic equation and solve for the values of x that will come out of this solution, okay? Now, we just see our x is going to be minus b plus minus the square root of b squared minus 4ac over 2a. You can refer to this video, it will show you how to use the quadratic equation, and then you can again check it. Towards the end of that video, you will see where we do grouping method. You can use those two methods, but I'm using the quadratic equation because it's straightforward to the answer, and then we're not going to I'm just going to plug and get the solutions, okay? Now, what we do is we have our solutions for x. Our roots will be x equals to minus b is 8 plus minus the square root of 8 squared is 64 minus 4, a is 5, c is minus 4, everything over 2 times 5 is 10, and then we have again just write minus 8 plus minus the square root of 64 minus 4 times 4 times 5, that is 20, times 4 is 80, that is 144. So we have plus minus the square root of 144, everything divided by 10. Now we have our first x as minus 8 plus square root of 144 is 12, everything divided by 10. Or we get our second x as minus 8 minus 12, everything divided by 10. Okay, and this one here is our minus 2, because we have there minus 8 minus 12 is minus 20 divided by 10 is 2. So we have minus 2 there. Our other solution that we are looking for is minus 8 plus 12. That is 4. 4 over 10 is 2 over 5. So our other root is 2 over 5. And then we have answered the following question that was saying we should find the other root. Okay, the next question was saying we should find the other root. For confirmation that the r is equals to 5 is the solution, this is the confirmation, because we get our solution as x equals to, because when r is 0 we don't get this solution, that is x equals to minus 2. But when r is 5, we are able to produce this. So again, remember when you plug 0, our quadratic equation falls away. We don't have a quadratic equation anymore. We just have a linear that is 3x, it was 3x, I think 3x minus 4 equals to 0. That is a linear equation. We don't want that. Okay. We also don't want to leave without checking this checklist. Okay. So make sure you hit the subscribe button, you like, and then you comment, you share the video with your friends as well. Okay. Let's proceed. Now, please take this moment and try number 3 by yourself, and let's check it in 3, 2, 1. Okay, what can we do if we encounter a question like this? It says the equation 2x squared plus m minus 5 into x minus 8 equals to 0 has roots of equal magnitudes with opposite signs. Find the value of m. What is the value of m that will make this equation to have equal magnitudes of opposite signs? Okay, remember the quadratic equation. when you sketch it as a graph, you will find a parabola, okay? A parabola that looks like this. A parabola, in this case, our parabola will touch at -8. -8 is there, and then it must be of a positive A. It must be concave up like this, okay? Now, it will be like this. It will be of equal magnitude, maybe -3 and 3, if it's not shifted to the left and to the right. And if it is written in the form of ax squared plus bx plus c like this, the b is the one that is responsible for the shifting to the left and to the right. If the b is not there, okay, meaning if b is 0, we just have ax squared plus c, and then it will have equal roots with opposite signs. That's what the question is looking for. And now do we answer the question? We say, okay, if it has equal roots, m minus 5 should be equal to 0, and m should be 5 for equal roots with opposite signs. Let's test if this is true. If m is 5, is it true that it will have two equal roots? Okay, let's check. We have 2x squared, 5 minus 5 minus 8, we have 2x squared. 5 minus 5 is 0x minus 8, that will be equal to 0. Take out the common factor of 2, or we divide everything by 2, we have x squared minus 4 equals to 0. Even if we took out the common factor of 2, we'll just divide both sides by 2, and then we have again this equation here. Okay, having this equation, we just have to open two brackets like that, and then we say, are we going to put our x and x plus and minus, the difference of two squares, 2 and 2, and then we have our x as minus 2 or our x as positive 2, and these are 2 and 2 equal magnitude. The one is positive, the one is negative. Okay, now we are done answering the question. Thanks for watching this video. Please ensure that you subscribe to this channel for more videos, and if you find it difficult to subscribe, you don't love me, and I believe my God will come through for your heart. Bye.